to the cloud services that are provided by Amazon, Microsoft, or some other vendors. So when you take out some kind of things like latency, bandwidth, and different parameters, and finally based on those parameters, you can say that the performance is which performance is good, and that gives out efficiency. So providing a good performance in terms of efficiency is one of the major goal of cloud computing. That's also to be taken as a part of design objectives for any sort of cloud establishment before it is coming into the market. So our architectural design of storage clouds, and certain kinds of things like cloud management, which receives the user's request, finds the correct resources, and then calls the provisioning services which invokes these resources in the cloud. I'm just reading out these points. Cloud management receives the user's request, so find the correct resources. So sometimes, so whatever the whatever the requests that are generated, that will be received by the management side, and based on that, the whatever the resources that are needs to be provided to the user and will be provided. So that is also one of the major point. And and the cloud management software, this cloud management is one of the base thing for all the entire cloud services which are providing, because any sort of issues to be solved at the cloud management side. So these particular services needs to support both physical and virtual machines. That means if there are any problems at the management side, also the unexpected failures have come across the based on the physical data centers, also always that should be ready with some other dump or some other servers, though, so that could gives out you the best quality of resources. And one of the most important thing when you when you start designing. Sorry. Sorry. Someone is saying something. Fine. Okay. So. So one of the last most important thing is security in shared resources and shared access of data centers also pose another designing challenge, one of the best designing challenge, because many sort of resources nowadays. So you may observe an organization like Wipro or Infosys have different branches across our city itself. There are 4 to 5 branches. They may share their own resources. The same cloud services will be used by at different locations. So in those particular cases, you come across these shared resources or shared access of data. So one of the biggest challenge is that what sort of security provisions are given when this shared access or shared resources are given, though they are of same sort of organizations, but they are in different locations. In the similar way, giving, suppose in some cases, a client who comes to an organization where he wants to do his project. So the organization may do this particular project which the client needs. So whenever they are doing, they have to discuss the project with client. So again, the resources again will be shared across the online. So what sort of security provisions are given there? And so at the data center side also, what are the security mechanisms that are used? Those also plays a major important role. And the platform needs to establish a very large scale high performance computing infrastructure. So all these things, before we discussed about the security part or the management software or certain kinds of request which is generated by the user, managed by the management, and security. So apart from these things, one of the most important thing is that in order to provide all these things across different locations, across different users, and high performance computing infrastructure is required. So that is also one of the most important things. So when you talk about this high performance infrastructure, so the hardware and software systems which are combined to make it an easy and efficient to operate. So those are all these things which are more kinds of challenges for the design of this particular cloud computing services. Okay, and few more things like system scalability, so which can benefit from cluster architecture. So if one service takes a lot of processing, power, storage capacity, or network traffic. It is servers and bandwidth, or data could be put into multiple locations. So that means system should, as of we discussed in the previous thing also, if one of the service takes lot of processing, so again, so if it is completely dependent upon one server, it again may enter into the unavailability part and bottleneck problems part, or whatever it might be. So for that, these things, more servers will be added as a part of mirror servers, and the processing is shared across these things. So best example is one of the email that can be put in 3 disks to expand geographically separate data centers. And there are key driving forces behind cloud computing are the ubiquity of broadband and wireless networking, and progressive improvements in internet computing software. So some of the forces which we discuss these things: cloud users are able to demand more capacity at peak demand. I'll read out these points and I'll explain. Cloud users are able to demand more capacity at peak demand, reduced cost, experiment with new services, and remove unneeded capacity, whereas service providers can increase the system utilization via multiplexing, virtualization, and dynamic resource provisioning. So some of the forces which require a lot of improvements in terms of this internet computing software, in terms of cloud computing, are explained here. So where, so as per the users nowadays, one of the best examples, so most of the software company employees are working from home these days. So they require more capacity, because working in an organization and doing their work is different. And again, the resources are shared across the net. So everyone is doing their work by using this cloud computing services itself, because they might not work on the public domain. They have to work on their own organization, that comes to the what we call problem of unneeded capacity. That means the people who are not required those services are again provided. So those things should be removed. And so these are all these things which are at the user end. And so in order to provide all these things, so at the service provider side, they can increase their system utilization. So by giving the multiplexing services, you all very well know about the multiplexing concepts. So where a single what we call service is provided in a multiple signals way. A single signal. You can take the examples of one of the best example is your when you talk about multiplexing part, your multiplexes, IMAX multiplexes, or PVR, or whatever it might be. That means a single screen is again shared back with different single building is shared back with different screens, and performing sometimes the same screens may give same different screens may provide the same task or same movie or whatever it might be. So multiplexing, that is a very layman example. So when you talk about the concept of computing or mathematics part, a single signal is again way back to the output in a different way. That means a single signal is taken, and again that is provided into 3 or 4 different ways. That is one of the best example given. So that means this is taken here for the service providers can provide the same systems by using this multiplexing concept, same type of computing by using this multiplexing concepts, virtualization concepts, and dynamic provisioning is also should be provided. And clouds are enabled by the progress in hardware, software, and network technologies, so which you can observe as a part of this particular figure. So cloud enabling technologies in hardware, software, and networking. So what is the technology that has been given, and requirements and benefits have been given. So if I'll study a few things: fast platform deployment, fast, efficient, and flexible deployment of cloud resources to provide dynamic computing environments to users, and web scale communications, support e-commerce, distance education, telemedicine, and all the other things, and few other distributed storage activities in terms of large scale storage of personal records. I'll stop here. What I am discussing, guys, what I am discussing, this is little bit theoretical, and most of the points should be covered. So I'll hold for more number of times in order to know that the status of what you are getting. So what we are discussing, guys, are you people there?
Yes, sir.
Okay, go on now. What we are discussing?
You were telling us about some design issues which should be managed in order to make the software efficient. For
Okay,
example, security issues or scalability.
okay, thank you. What is your number?
528, sir.
Okay, fine. Next, 513.
Yes, sir.
Yes, what is this topic name?
Architectural design of compute and storage cloud, sir.
Okay, thank you. And 531. 531. Are you there? 531. Not there. 17550. Five 35.
Yes, sir.
What are the major design goals of cloud computing platform?
Virtualization, scalability, efficiency, and reliability.
Good, thank you. Okay, thank you. Right. So we are discussing the concept of architectural design of computing and storage clouds. So basically, this is the concept of how if one of the cloud services are going to be established, or a cloud environment is going to be established. So it gives out a clear picture what how the storage activities should maintain, and at the user end what are the services required. Okay, how the data center should provide the services by using the cloud management of virtualization managers, or cloud managers, by using the cloud managers, and how they can solve the problems. Okay, and what are the basic main goals of entire cloud computing platform. Okay, these are all these different things, so which gives out a clear picture of the design of how the design architectural design should be. That means why we are discussing this design part. So you all very well, you have studied about the software engineering subject, where you have seen things like the waterfall model, analysis, design. Okay, before a product is going to be established. So it goes in a stepwise way. There are certain other things also. I'm taking a very fundamental part of waterfall model, where many people know about. And so when a project is going to be designed, so it goes under the requirements analysis part. So in the previous class we discussed about the requirements at the data center end. Okay, so in the similar way we are discussing about the design part of cloud computing in this class. As it slowly goes on, analysis part, implementation part, okay, finally the maintenance part. So all these things will be covered across these things. So as a part of this class we are much concentrated towards the design part of cloud computing platform. Okay, so next part is about generic cloud architecture. So you can see this particular figure. Okay, so where it consists of data centers, a public cloud. You can observe a public cloud. Okay, so a public cloud which consists of a data centers and clients. So how the what are the different things that are required at the client end, and service catalogs which are maintained by the provider side, and security and performance monitoring is also maintained at these things. So this shows the security. This figure exactly shows the security aware of cloud architecture. So the internet cloud services. So these servers are provisioned to the user to perform the collective web services or distributed applications at the data center resources. So that means if the user needs these servers, usually servers which are provided from the provider side. So in order to provide the services in terms of web services or distributed applications or whatever it might be, so the cloud platform is formed dynamically by provisioning or deprovisioning the server softwares or database resources. And the servers which you can see as a part of this particular figures in the cloud can be of virtual machines or physical machines, and there will be user interfaces and provisioning tools in order to deliver all these things. So this this gives out a clear picture of what exactly how the generic cloud, very basic and generic cloud architecture. So and as well as the security aware architecture, you can again see these points. The servers which are provisioned on demand to perform collective web services or distributed applications, and the cloud platforms which is formed dynamically by provisioning or deprovisioning servers, softwares, and database resources. Servers in the clouds can be physical machines or virtual machines. User interfaces will be are applied to request services. Provisioning tools. So things required at in this thing are how they are provided, in the sense what user requests. So servers will be provided. So especially in terms of web applications and web services or distributed applications, and servers will be usually of physical or virtual machines. And apart from these, the user interfaces. And the cloud computing resources are built into the data centers, which are typically owned and operated by the third party provider. Again, what is a third party provider? So can anyone answer? Can anyone answer who is a third party provider?
Maybe someone from outside the organization who provides services for money.
Okay, how he can provide? Can you say any real-time example? Okay, fine. I'll go with a very basic example of the business applications, marketing business applications. So you people all very well know about this Bata shoe shops or Chappal shops. So usually these Bata shops are across different locations. So is it the original company which is serving across different locations? Can I know the answer? Guys, are you people there? So, do you get my point? Do you get my point? I'm going back to the normal example, very normal example. I'll come back to the normal. I'll come back to the technical side once again. So we are providing the Bata showrooms or different other Bata shops, shoe shops across different locations. Is it the original company all over the India is providing the services? Okay, some are originals and some are. So so usually not many locations have these particular shops, but okay, we can count around 1,000 or 2,000, whatever it might be. So some people might be taking their name, this Bata name, and they'll be having the negotiations and they'll be selling these things. Okay, so these are all the people which we can say it as third party people. That means original Bata company people are not selling here. They may give their products to these shops, or they may not give also. Both cases will be there. Both cases will be there. But most importantly, if the brand name is used, so that comes under Bata itself. Okay. So in the similar way, when you talk about, there will be different vendors like Microsoft and Amazon. They'll be having negotiations with third party people. Again, they'll be providing the services. Okay. Or else sometimes these Microsoft or different other cloud services can also be third party providers between the two different people. So here there exists a lot of confusion when you say it as a third party provider. Okay. So in terms of security part, trust is one of the most important thing when you share your resources across the online activity. Okay, so at that particular time, trusted third party should be there. Okay, so that's why usually the standardization or the trusted third party plays a major important role in the providing cloud computing services also. So usually data centers will be built across by many larger organizations, and so these things will be operated by third party provider also sometimes. So in order to have some sort of an issues in terms of financial issues, so data center will be operated by some other provider also, but it runs with